Today we're working on graphing using intercepts. So we're going to be needing to use some vocabulary. The first vocabulary word is x-intercept. The second vocabulary word is y-intercept. So we're going to go over what those mean in just a second. So I'm going to read this to you. Because 2 points determine a line, a quick way to graph a line that does not pass through the origin, that's the 0, 0 center part of the graph, is not horizontal and is not vertical, is to find the x-intercept. That's the point at which it crosses that axis. The x-intercept, we've got the y-axis here and the x-axis here. The x-intercept is where it crosses the x-axis, and the y-intercept is where it crosses the y-axis. So, for example, here, that would be my y-intercept, and that would be my x-intercept. So these values can be found by letting 0 or y equals 0 and solving for x, and by letting x equal 0 and solving for y. So looking at this example here, if we have this equation here, 4x plus 7y is equal to negative 28. We're first of all going to plug in x is equal to 0. When we do that, just that becomes 0, so that's the new equation here. 4 times 0 plus 7y is equal to negative 28. So we can solve that just by dividing by 7, because the 4 times 0 goes away. And so then we're left with y equals negative 4. So 0, negative 4 is a point on that line, and it happens to be the y-intercept. It's actually going to be on this axis here, the y-intercept. So to find the x-intercept, we're going to let y equals 0 in the same equation. So here, instead of the x being 0, y is 0 for that. So we're going to solve for x. So 4x plus 7 times 0 equals negative 28. So if I solve that, I'm just going to divide by 4. I'm left with x is equal to negative 7. So negative 7, 0 on the graph is the x-intercept. So again, once again, the x-intercept is on the x-axis. The y-intercept is on the y-axis. So now we're going to try and graph, or at least find the x and y-intercepts of equations. So when I find the x-intercept, I'm plugging in y is equal to 0. When I plug in the y-intercept, that's when x is equal to 0. I know that seems like it should be the other way around, but when x is equal to 0, it's when it's crossing that vertical axis. When y equals 0, it's when it's crossing that horizontal axis. So we're going to plug in here into this equation. Let's start with the x-intercept. So we're going to plug in then y is equal to 0. I'm just going to rewrite it here. So if y is equal to 0, 3x plus 2 times 0 is equal to 6. So 3x is equal to 6. So that means x is going to equal to 2. So that would be the x-intercept. For the y-intercept, I'll do that one up here, it's when x is equal to 0. So it's going to start with 3 times 0. So now I'm plugging in x is equal to 0 plus 2y is equal to 6. So I'm going to be left with 2y is equal to 6. So y is going to be equal to 3. So that's what you're doing. You're plugging in 0 for x and 0 for y, and then solving for it. I'm going to try this one on the bottom right as well. And so when I'm solving for the y-intercept, plug in x is 0. When I plug in the when I'm solving for the x-intercept, y is equal to 0. So I'm going to start off with the x-intercept. So 3x minus 4 times 0 is equal to 12. So 3x is equal to 12. The x-intercept is going to be 4. The y-intercept, I'm going to do over here to the left, that's when x is equal to 0. So I'm going to end up with negative 4y is equal to 12. So it's going to end up with y is equal to negative 3. So these other two you should try yourself. So this one here and this one here. And it's plugging in 0 for the x and then 0 for the y. Actually, for the x-intercept, it's plugging in 0 for the y and then 0 for the x, for the y-intercept. So one thing that makes this really easy to graph things then. So if I look up here, I've got this equation here. I'm going to solve this equation by figuring my intercepts. So if I'm plugging in, if I'm trying to figure out my x-intercept, that's going to be when y is equal to 0. So I'm just plugging in y is equal to 0 there. So it's going to be 0 is equal to x plus 2. So x is equal to negative 2. That means when x is negative 2, y is 0. So that's going to be right about there. So now I'm going to do the same thing, except for this time I'm going to plug in x is 0. So it's going to be 2y. So y is going to equal 1. When x is 0, y is 1. So my line, just by graphing those 2 points, is going to be approximately there. And I can do that because I graphed using intercepts very quickly. So if you have a graph like this, it's even easier. You're just identifying the point where it crosses the y-axis. So the y-intercept for this one's going to be 1, 2, 3, 4, 5. So the y-intercept is 5, and the x-intercept is where it crosses the x-axis. So the x-intercept is going to equal negative 4. So when there's graphs, you're just identifying the points where they cross the axes. So this is a word problem, so just to practice those. It says here, you make and sell decorative bows. You sell small bows for $3 and large bows for $5. I'm guessing those two things will be really important, so I'm going to underline them. So small bows and large bows. You want to earn $60 per week. The situation can be modeled by 3x plus 5y is equal to 60, where x is the number of small bows and y is the number of large bows. Find the intercepts of the graph. Graph the equation. Give 3 possibilities for the number of each type of bow you can sell to earn $60. How can you check the graph of the equation? So what I'm going to do is I have my equation here. It's all written out nice and neatly. So what's my, when x is equal to 0, I'm going to have my y-intercept. So it would be 3. So it's going to be 5y is equal to 60, so the y-intercept is going to be 12. So that's where that is. That would be 12. And then my x-intercept is going to be where, let's see here, where y is equal to 0, so 3x. So x is going to equal to 20. So what that means is I can sell 20 bows that are $3 or 12 bows that are $5, and I'll make the $60 I need to make. Now any point on this line also should work. So because you could sell some of the small bows and some of the large bows. So that's what they're talking about in terms of a third possibility. So if you look closely, you can find one there where it crosses closely.